Our third video for lesson 2 is going to start all the way down here in part F. This is going to be, we could do a ton in this topic if we really wanted to. And if you take physics, you will get into this a lot more than what we will end up doing. But one big reason we talk about vectors is that they help us discuss the idea of work. Okay, how much work is being done? How do we describe that? Again, we could do a ton with this topic. So they give us a very basic definition, and I'm sure we're going to end up talking about this and a few other things in class, but just for the sake of the video, I'm just going to go through the definition and show you how we would typically use it, and then I'm sure we'll have some things again to discuss in class. But if we have a vector called F and it's a force moving in a certain direction, so some effort that we're applying in a certain direction, then the total work done by that force in moving an object from point A to point B is defined this way. The work is going to equal the product of these two ideas. And there's one thing that I'm missing. Hopefully I wrote it in yours, but hopefully I put a little arrow, if I didn't do that, above the A and the B. And that's important because they already tell us that capital F is a vector, and when it's written that way in bold lettering, kind of in italics, I suppose, that's pretty common that means it's a vector. And now when you finish the definition here, we put that arrow above A and B, that's another way of describing a vector. So work is simply a dot product of two vectors. One happens to be involving the force that's involved, and the other one is the distance that it's moved. So just that's how physics people have described or decided to talk about the work being done. So our question, our example here, again, just keep in mind it's a dot product of two vectors, is to find the work being done by a 10-pound force acting in the direction of 1, 2 and moving an object 3 feet from 0, 0 to 3, 0. So let's start with, I think, probably the more complicated one, the force idea. Okay, so it's going in a direction of 1, 2. There is something. Let me get rid of a little symbol there. Okay, we have a force that's going in the direction of 1, 2, so right up there. Okay, and when it does that, the magnitude is 2.19. And in this sort of question, that's going to represent the force that right now it's doing. So if our units here are 10 pounds in the end is what we want. Right now this picture is saying that if we just went this far, if the vector was just represented going that far, the magnitude is only 2.19 pounds. So we need to figure out how to keep it going in this direction, but kind of show that in the end it's going to go all the way up to something like 10. It might even go off the screen. It's going to go way up here. That's the vector that we need to represent. Okay, so how do we do that? Well, we're going to take the vector that we know, which is 1, 2, and we need to kind of shrink it down until it is at 1, a length of 1, so that's a unit vector, and then we're going to mathematically stretch it out so it has a length of 10. And we've done these kind of questions before, just not in this sense here, I guess, so I would want to go all the way out to 10. Okay, so that's our goal. To build this vector, we're going to take the 1, 2, we're going to create a unit vector, so shrink it down, and then we're going to multiply by the length that we want, so stretch it out to a length all the way to 10. Okay, that's our goal here. So mathematically, that it will look something like this. We want to start with a vector, and our vector is, let's see, I want to call this F. Okay, vector F, the force. Okay, it's going to be related to 1, 2, but I need to get it to have a length of 10. So maybe I'll just put a little star right here. Okay, I want to find the magnitude of this original vector. So maybe we call this, for now we're just going to call that vector u because we've been doing that a lot. Okay, so the magnitude of u then is going to be the square root of 1 squared plus 2 squared, which is just the square root of 5. Okay, so I know the magnitude of this vector is square root of 5. And so what I'm going to do is take the vector that we started with, I want to shrink it down to have a length of 1 in the end. Right now, square root of 5 is about 2 point something, and we saw in our sketchpad file that the magnitude was 2 point something initially. I want to shrink it down. So I'm going to take this. I want to divide by square root of 5, or I want to multiply by 1 over square root of 5. So this by itself is going to create that unit vector that we talked about. Taking the vector 1, 2, shrinking it down to the right size. Okay, and then I want to stretch it out to a length of 10. So all that kind of complicated stuff is visually just going to show you what happened to that red arrow where I started with 1, 2, shrunk it down to have a length of 1, and now by multiplying by 10, I'm stretching it out to have a length of 10. So, different color real quick, I'm just going to take this idea, this fraction, and distribute to both parts. And I'm going to do the same thing with the 10. I'm going to take that 10 and distribute to the both parts. Okay, and when I do that, that's going to be how I describe vector f. So I've done that already. You can try it on your calculator if you want to. But in the end, I get 4.47 and 8.94. Okay, so that describes, obviously those are not exact answers. That would go quite a bit further. And then our vector for AB, different color here. Okay, in this case it's an easy one. You'll have some more challenging ones to work on in class. But it went from 0, 0 to 3, 0. That's where the object moved overall. So in the end it just went 3 to the right. So that was kind of the easy one to come up with. So visually, what does this mean? Let's take a look at that a second. Here's my coordinate plane. Okay, we're basically saying that this is point A, point B is somewhere right there. This object moved 3 spaces to the right, but the force that was working on it was going in the direction of 1, 2, and it had a length of 10, or it had a force of 10, and it was kind of being pulled in that direction, but it had, what it could do was, well, for whatever reason this object was fixed and it could only move to the right. It went 3 feet to the right. So that is a length of 3. So that's kind of an informal picture. We can do a better job in class if you want to. But now, what is the work that's being done? Well, our definition of work, according to our notes, is just to take the force vector and multiply it by you could say the movement vector. According to this, we have 4.47 times 3 plus, and then 8.94, that's a plus right there, plus 8.94 times 0, well, the second part's just all going to go away. 4.47 times 3 gets me 13.41. Again, those are kind of rounded answers. Now, this is an application. We really should have some units here. This is going to be something that we'll have to talk about again in class. The actual unit for this is something called a foot-pound. Again, we'll discuss that a bit in class, but you know, you're moving a certain distance. The work being done is you're moving a certain distance. You're using a force measured in pounds. You put the units together, you get foot-pounds. But this technically is something that does exist. So we will stop there. Jot down any questions.